aircraft in the circuit. So what do you mean by circuit? So if we talk of circuit, then circuit means the area within which this aerodrome has the control, that it is called as the circuit. So that is called as a circuit. Then so here, so some person will be working in this room, so they will be giving the control instructions from the start. Okay. So before this, we could have understood the terminologies. That first slide is missing. Like, where all the terminologies are explained. I'll try to find out. So air traffic control responsibilities. So so aircraft outside the circuit, but within the airfield areas of responsibility are handled by approach controller. So basically, the air traffic control responsibility lies in the controlling of in the control area. So basically, it is an extended area. So if you draw here, that if this is the tower, then so an area which is covered to 1.5 nautical miles. So that is covered under this aerodrome. So this is any aircraft which in this area, for example, this area, if it is any aircraft is rotating here, so this we call it as one circuit. So aircraft within this area means the aircraft says coming from somewhere and it is approaching here, so it cannot directly land it. So first it has to enter into the circuit. So once it comes to the circuit, then it takes the permission from this ATC, air traffic controller. So then once the air traffic controller gives the permission to land, then it will land into the runway. So that is how exactly the aircraft movement takes place. That is what here explained. So aircraft outside the circuit but within the airfield's area of responsibility are handled by approach controller. There are various controllers. In fact, there is something called Air Traffic Advisory Service, Air Traffic Control Center, and Air Traffic Control Services. So the difference between the air traffic advisory system is that, so air traffic advisory is responsible to the movement of aircraft after they take off, when they enter into their flight level, and from there they exit that aerodrome area and then they go in their designated path. So that path is monitored by air traffic advisory services, where they will be giving the necessary service when the flight is flying in the instrument flight routes. Okay. Just a minute. Let's see here. Okay. So the work with the radar screens and control aircraft departing and arriving. So this air traffic controller is basically monitoring the aircraft within their vicinity of 1.5 nautical miles. So they will be controlling this through radar movements. So the other responsibilities of air traffic control is to monitor the aircraft flying between the airfields and locate at the air traffic control centers. So basically it performs the three duties: air traffic control, that is air traffic control within the control area, and flight information services within the flight information region. Then alert service for search and rescue operations. So one operation is, as I discussed, that is air traffic control. So it means any aircraft which comes here. So any aircraft which within this 1.5 nautical miles radius, so any aircraft is there, so that monitoring and permission for landing or any such instructions are given to this aircraft. And the second one is the flight information. For example, uh, some flight, say for example, it is traveling from one place to another place. So when it is moving through this aerodrome or through this air traffic controller, then even at that time, it gives the information, necessary information which is required for that aircraft to pass that airfield. So even that services is provided by air traffic controller. Then alert and rescue services means, for example, if any aircraft uh, it got misses, if it is not under any of the locating any of the ATC cannot able to locate which the aircraft, then if it got missing, then the air traffic controller, the last air traffic controller which has found that aircraft in their radar, so that air traffic controller reports the issue and they will generate an alarm for search and rescue system. Then immediately the search and rescue system will come into action and they start finding the aircraft from this last location. So if it loses the contact with any of the ATCs or like that. Okay. So then air traffic advisories services, as I said, so they'll be monitoring when the flight is in IFR rules. It means IFR stands for instrument flight rules. It means the aircraft is flying with the flight rule conditions, instrument flight rule conditions. So in such cases, then the advisory services will give necessary information for navigations and route advisory services and so on. So the good communication between the airfield control towers, that is ATC, and air traffic control radar units are vital. It's very important, and all are like by telephone lines or fixed. I'll just skip this. Airfield hazards at the background. So at airfield, where taxiing on gross is permitted, bad ground is identified by one of the three methods. That is this. It means a white canvas marked with a red band. It means so that is the area where the aircraft cannot enter. So basically, on the land after landing or before takeoff, the aircraft basically it will be on the land. So there are few areas where the aircraft cannot enter, and those are identified by different markings. So one marking is this. So it will be having a white canvas in which in the middle there is a red band, so that indicates that it's an hazardous area. And there is also one more where it is kept like this, and there will be yellow and black markings on the like a strips on a solid block. So that is also indicating that the movement on that particular area or land is restricted, or it might be hazardous for an aircraft. And the third one, it might be a yellow flag or light which is staked on the land. It might be a lamppost kind of thing which is of yellow mark or yellow flag. So that is also indicating that it is not suitable for an aircraft movement there. Next, coming to radar. So radar stands for radio detection ranging system. So it is basically to locate the aircraft which is going away or coming towards the aerodrome or the air traffic controller. So basically that will works on the principle of transmitting a pulse, electromagnetic pulse, a high energy pulse. So when it collides with any object, say an aircraft, then that reflected pulse is calculated. It is received again with the same antenna. So if I write here, so we have the antenna here. If this is the antenna, and if it is transmitting some pulse in this direction, that at certain distance where aircraft is there, for example, I'm such a bad in drawing. So assume there is an aircraft which is approaching. Okay, so then this pulse which is transmitted, a high energy pulse, then it gets reflected from this. So again it will come back in the same direction. So it is not necessary that it has to come back in the same direction, it may go in any direction. So few signals, again it will come back in the same direction, but the magnitude of that such signal will be very small, and that is measured by this antenna. And the time it takes to travel and come back the same pulse. So that is, we use the formula to calculate the distance. How far is that aircraft from that particular air traffic controller or the aerodrome? So that is calculated in this way. So we'll transmit the pulse. So that and we'll collecting the reflected pulse and the time it requires to travel in the forward direction and travel back in the reverse direction. So that time we calculate, and that will define, and using that time calculation and the frequency of the pulse, so then we define the speed of the aircraft. So that is how the system works, and basically we call it as it works on a echo system, means echo reflected signals. So just skip this part. So there is a one more concept which is used in the airport. So that is called as ILS, Instrument Landing System. So in majority of airports, so this instrument landing system is installed. If you can say this, so basically there will be an antenna which is located at different height. So this will guide the aircraft automatically to land. So this is an auto landing system. It is an instrument landing system which will guide an aircraft to land it. So to better understand, let me show you some video on this. I wanted to show on this. So I'll just share this video to you. Hope you can see this screen. Can you able to see the screen? Okay, so just watch this small video.
Sir, it's not audible.
It's not audible?
No, sir.
So how to make it audible?
So just
Audible
remove
now?
the headphone.
Okay.
We have an option called Chrome Share, sir.
Sorry, come again.
We have an option called Chrome Share, so it will share our audio also.
Where? In settings?
In Chrome, sir, in Chrome, Google Chrome.
Okay. Where exactly?
So
Otherwise, if I remove this headphones, can you able to listen?
Yes, sir. Just remove the headphone. The
Okay.
laptop microphone will go.
chart with important data like
Is it
the
audible
ILS
now?
frequency and
Yeah,
identifier code, the ILS
Okay, I'll just
inbound
play
course
from
and glide
here.
for instrument, the L for others, and you can land great open, the L for landing and the S for system. So the instrument landing system is a ground-based radio navigation system giving pilots the lateral and the vertical guidance towards the runway as they are in approach and IMC. To fly an ILS approach, the aircraft has to be fitted with an adequate ILS receiver to display and convert the picked up signals on the cockpit instruments. Besides that, you need the necessary ILS approach chart with important data like the ILS frequency and identifier code, the ILS inbound course and glide slope angle, the given minimum descent altitude or heights depending on the ILS category, and last but not least, the go-around procedure. Okay, now let's talk more about the ground-based system. Now the system consists of two antennas sending out on one tunable frequency. The so-called localizer antenna is normally located beyond the end of the runway and generally is built up out of several pairs of directional antennas. They send out radio signals in the horizontal axis of the runway. Let's look at this picture right here. The localizer antenna is emitting two lobes which are frequency modulated to 90 Hz on the left-hand side of the runway centerline and 150 Hz on the right-hand side. Now, just to get a better understanding of the localizer antenna, imagine each lobe would be a massive light beam. Now, 90 Hz side would be a yellow light and 150 Hz side would be a blue light. Now, let's say you're slightly to the right of the runway center line, so the light you would be seeing is primarily blue, meaning you would have to fly more to the left where the light lobes overlap, creating a green light, and then you know you're on the center line. Obviously, there is no such light besides the palm beam, but that's a whole other story. But you get an understanding how to interpret the converted ILS signal on your ADI, your HSI, or PFD. Now, instead of colors, you have this diamond indicating your position relative to the runway centerline. So if the diamond would be to the right, or let's say the runway centerline, you are left of it and have to correct your heading to the right to join the localizer and vice versa. Also important to know, at the same time, the localizer transmits the so-called ILS facility identification code. So what's that good for? Now, because the frequency range for the ILS is fairly small, you could pick up the wrong ILS frequency of a nearby airport. Therefore, each ILS sends out its own Morse code. For example, the ILS identification code for John F. Kennedy Airport, runway 04 right, is India Juliet Foxtrot Kilo, which will be displayed in your ILS receiver instrument, or you have to actually listen to the Morse code and compare it to the one on your ILS approach chart. Please comment below what type of airplane you're flying if you still have to self-tune the ILS frequency and listen to the Morse code. That'll be great, thanks. We have now established the lateral guidance towards the runway. Let's talk about the vertical axis. Now, this axis is defined as the glide slope. Now, the glide slope antenna is similar to the localizer antenna, only sending out the signals to the vertical axis towards the runway and is based perpendicular to the touchdown zone. Now, imagine the light beam example I mentioned a minute ago. It works the same, just at a 90-degree angle to the localizer beam. Now, in most cases, the glide slope angle towards the runway is 3 degrees, which is an angle presenting an adequate vertical descent rate in coherence with the approach speed, and it's shallow enough to constantly reduce your speed by extending slats, flaps, plus the landing gear. But more about that in the next episode. So there's another diamond presented on your instrument showing your position relative to the glide slope. Now, if the diamond is above the center, I'll give you the indication you are below the glide slope, so then you have to reduce the vertical speed or even level off to recapture the glide slope. If the diamond is below the center of the instrument, you're then too high. So again, correct your vertical speed to rejoin the glide slope. Now, this sounds easy, but be aware, if you pitch further down, you gain speed. If you level off, you reduce speed. So it's all a matter of pitching power and at the same time extending slats, flaps, and doing ATC communication. So it's not that easy. Obviously, there are glide slopes which are steeper, very often due to mountainous area or obstacle clearance limits which need to be met. For example, runway 24 at Naples, Italy is known for its steeper ILS approach than usual. And here comes a little contest. Which airport has the steepest published ILS approach in the world? The first correct answer gets pinned. Okay, we've now established the two main components of the ILS providing horizontal and vertical guidance towards the runway. But how do you know how far away from the runway threshold, which is absolutely essential for your speed management? Now let's say you're at 2,500 feet and you know the glide slope angle towards the runway. Well, you could quickly get out your calculator and do the math. All in bad weather and whilst monitoring your instruments, that's kind of difficult. So therefore, all the ILS systems have three marker points: the outer marker, the middle marker, and the inner marker. So when flying over the outer marker, a little blue light will start flashing on your instruments and a corresponding beeping code can be heard. Comparing that with your map, you then know, okay, I'm passing the outer marker, you should have that altitude at that given distance. The outer marker and the middle marker are still out there, but I haven't heard an inner marker in a very long time. Nowadays, there's the third antenna installed called the DME, Distance Measuring Equipment, which will give you a slant range towards the runway. Now, making it a lot easier to monitor your distance, but your aircraft has to be fitted with the appropriate DME receiver and an instrument with which you have to tune in the corresponding DME frequency. But even better are the ILS, which come with a built-in DME indication. If the letter D is prior to the identifier code, you know the ILS comes with a DME signal. The accuracy and the range of the ILS can vary from airport to airport, but all published ILS have to meet the standard ICAO Annex 10 guidelines, which are roughly 100 pages long. But generally speaking, the localizer shall be receivable with an accurate signal of at least 25 nautical miles from the runway threshold at plus minus 10 degrees to either side, at 17 miles plus minus 35 degrees, and if necessary at a 180-degree angle within the 10 nautical mile radius. At some airports, you can also use the localizer back course or back beam, meaning you can approach the runway from the other side, but without a glide slope indication though. But keep in mind, if your plane isn't fitted with an instrument capable of switching to the localizer back course approach, the indications will be the other way around. And the glide slope has its best accuracy at plus minus 8 degrees to either side of the runway centerline within a 10 nautical mile range. So I hope you enjoyed this basic introduction video of the ILS.
Yeah. So I hope you got some basic idea about this instrument landing system. Okay, so basically there will be two major antennas will be there. So one which is to monitor the the horizontal movement, and then to the vertical movement. Means vertical movement is required how above you are from the ground, that is the altitude, and the vertical antenna is again to make you where exactly in the space you are, whether to the right side of the runway or to the left side of the runway. So to make that clear, so this and it will help at the greater extent for a pilot to smoothly land at the runways even if the visibility is poor. So in the poor visibility conditions, so it all depends on these instruments where the pilot take a call and performs the landing operations. So is it clear? Was the video was audible? Okay. So there is something called aerodrome reference point. So aerodrome reference point is another point where in the aircraft, it is the center of the runway, which is marked as the reference point, as aerodrome reference point. For example, if you have, say, I'll just for the two runways. So for example, you have a runway here. So this is your runway. And you have one more runway at, say, a 45-degree angle to this. So this is one runway. in the middle, and this is the another runway in the middle. So then the center of this is marked maybe somewhere here. So there will be some marking here which is indicating that is the center of the aerodrome. So that is called as the aerodrome reference point, that is APR. And the aerodrome traffic zone is extended. So aerodrome traffic zone, for example, this is the aircraft, then here your ATC control will be there. So then the radius of this entire, as I told before, so this depends on 1.5 or 1.5 nautical miles and to a height of 20,000.
Sir,
Yes.
you're not sharing the screen.
Oh, sorry. Is it visible now? Visible?
Yes, sir.
Okay. So what I was telling is that, for example, you have the runway. So one runway is here. So let me call this runway as A. And there is a one more runway at a 45 degrees. Say this is B. And then aerodrome reference point is somewhere the middle of this the runway. So that is the point is marked here. So this point we call it as aerodrome reference point, ARP. So it is indicated with some some kind of board will be there which is indicating that this is the center of the reference. So this will help. Why this is important? Because this will help the say any aircraft approaching, for example, any aircraft which is coming here. So it will help that aircraft to identify how far he is, or if he cross this marking, the first marking, how far he is from the landing, or how much the runway is left out. So to indicate that this ARP, the aerodrome reference point, makes a very important there. And I was telling that the aerodrome area, for example, if the aerodrome is located here or the air traffic control is located here, then the range of this aerodrome traffic zone, it depends on, say, it is 1.5 nautical miles. So it is 1.5 nautical miles radius and up to the ceiling. Ceiling means if you see this vertically, means how above or at what altitude it has the control. So it has a control up to up to 2,000 feet of the ceiling. So that is, we call it as ceiling. For example, every room has certain ceiling level. It might be a 15 feet, 12 feet. So likewise, the aerodrome ceiling is 2,000 feet. Well, in fact, I had one more presentation where all the pictorial representation was there. I'll definitely try to show you in the next session. I don't know where I put that. I'm not able to find it. Okay. So this is the basic introduction of the Airman-ship. So I'll just conclude this session. So in this session, we have discussed about basics of airmanship. So airmanship is basically the rules and regulations which an aircraft or everyone which is related to aircraft or the airfield or anybody who counts accountability. So they have to follow these rules and regulations to keep the aircraft safe on land as well as in the air. So that is the meaning of airmanship. So then airmanship, then we talked about the aerodrome. So aerodrome is any land or water body which includes any installations. Then aerodrome reference point is the center point of the runway, which is marked with some board. Then air traffic zone we have discussed. So it is 1.5 nautical miles with a radius and with an altitude of 2,000 feet. And then the air traffic control responsibilities we have talked about in this session. I think I could able to give you the little introduction to this airmanship. So in the next class, definitely we're going to discuss much more details about this. Fine. Okay, then we'll wind up today's session. So I will be sharing the attendance with you after the session. Okay. Jai.